Hello and welcome back. In the middle of making this, what I thought was only going to be the second video for 5.2, I just went away and I didn't realize it until I was done with problem 37 and my screen was frozen and I had to spend an hour and a half with Lenovo on the phone. They fixed my computer, but needless to say, I'm back to finish the lesson for 5.2. Keep our fingers crossed. This is the last and only video for that. The last video, I should say. So this will be called part C. So when I was finishing up problem 37, we had drawn the angle. This is our reference angle, pi over 3. And I had said that sine was square root of 3 over 2 at pi over 3, which is a 60-degree angle. But it's in the second quadrant. And so that means that sine, it actually goes cosine comma sine. Cosine is a negative 1/2, and it's negative because it's in the second quadrant, but sine is positive at a square root of 3 over 2. Tangent is sine over cosine. And so when we do the multiplying by the reciprocal, we get a negative square root of 3. And then our reciprocal cosecant, secant, and cotangents are here on the right. So problems 41 through 55 are asking us to use the calculator. So we're just going to get practice using our calculator. Hopefully you have a graphing calculator with you. There are apps that you can use on your phone for practice if you're borrowing from the school for exams. But you'll want to make sure that your mode is in radians. So notice where my finger is, there's a second key, and then the right of that is mode. So press on mode, and then you're going to look down the fourth row. It should say radian and degree, and you want radian highlighted. So for instance, number 41, we're going to put in sine. So the trigonometric functions are right where my finger is, above the 7, 2 above the 7, there's sine, cosine, tangent. And then just above that in blue, using the second key, using the second key, and sine will get you to that's going to be the inverse functions. I want to do 1 over, so we would do the reciprocal, so 1 divided by sine of whatever. So 41 is just the sine of a negative 3. So we're going to click on sine and then just put in a negative, not subtraction, but make sure you do a negative 3. And you should get a negative 0.1411. 45 is the tangent of 2. So we're going to hit the tan button, which is to the right of the cosine, and then put in 2. And we should get a negative 2.185. 2 to 3 decimals is good. And then we are making sure I'm at 47. So 47 is the tangent of 3 pi over 5. So we're going to hit our tan button, and then 3, and the pi is your shift key, well, your second key. And then above your division is the caret symbol, and that's the key you're going to use because in blue, let me zoom in here. See, in blue above the caret key, you can barely see it here, is the pi right there. Right there it is. And so 3 pi, and then we're going to divide that. It says 3 pi divided by 5. And a right parenthesis to close it, and we should get a negative 3.0777. 3.0777. Negative 3.0777. 51 is the secant of 7 pi over 5. And remember that secant is the reciprocal of cosine. Secant is the reciprocal of cosine. So to find that, we have to do 1 divided by the cosine of 7 pi divided by 5. And we get a negative 3.236. And negative 3.236. I'm sure I'm looking at the right one here. 3. So 53 says secant of 3.2. So again, we're going to do 1 divided by cosine of 3.2 parentheses, and we get a negative 1.002. And then we're going to look at number 55. 55 is cosecant, so we're doing 1 over sine this time. So 1 divided by the sine of a negative 2.5. And we get a negative 1.6709. We'll just go out one more. So negative 1.6709. So that's how we're doing our values. Now, if I wanted to find some trig functions in degrees, we would then change our mode up here and go over to degree. And so then when I'm out here and I say sine at 0 degrees, it should be 0. Okay. And if I do cosine at 0 degrees, it should be a positive 1 because it's in taking degrees, which is the same as 0 pi. Okay, but I better take my mode. So for right now, we're doing everything in radians. So just leave it in radians for now. Okay. So let's move on to problem 81. 81, 85, and 89 are all doing some mathematics with our sine functions, our trig functions, I should say. So number 81, they're asking us 81, 85, and 89. They're asking us to evaluate these functions. It says find the exact value of each expression without using a calculator. So the first one says 3 times the sine of pi over 4 plus 2 times the cosine of 3 pi over 4. So the sine at pi over 4 is square root of 2 over 2. So this is the square root of 2 over 2, 3 times that, plus 2 times cosine at 3 pi over 4. And so pi over 4 is my reference angle. But remember, 3 pi over 4 is in the second quadrant. And cosine is negative there. So I'm going to look at the reference angle. So for cosine, it's square root of 2 over 2, but it's negative there. So negative square root of 2 over 2. So this is 3 square root of 2 over 2 minus, because it's a plus times a negative, 2 square root of 2 over 2. So the square root of 2's over 2 are like terms, and we've got 3 subtracting 2. So we just have a square root of 2 over 2 remaining for 81. So this is fine. So 85 is a multiplication or multiplying tangent of pi over 4 times the secant of pi over 4. Okay, so we have the tangent of pi over 4. So pi over 4 is the actual reference angle, and tangent at pi over 4 is sine over cosine, which is just 1 because they're the same. So that's just going to be 1 times the secant at pi over 4. So the secant at pi over 4 is 1 over cosine. And so let's just do that right here. So 1 over cosine, which is the square root of 2 over 2. So it's the reciprocal of that. So it's 2 over the square root of 2. And if I want to rationalize that, I have to multiply by the square root of 2. So it's 2 times the square root of 2 over the square root of 4. So that's 2 times the square root of 2. Square root of 4 is 2, so that cancels. So that's just the square root of 2. So cosecant and secant should both be just the square root of 2 for the pi over 4 reference angle. So, oops. So this is just going to be 1 times the square root of 2. So the answer should just be the square root of 2 for 85. And then 89 says, let's find the tangent of pi over 3 minus the cosine of pi over 6. So pi over 3, tangent, we're going to go to pi over 3, and tangent of pi over 3 is the square root of 3. Subtracting the cosine at pi over 6. So cosine at pi over 6 is the square root of 3 over 2. So we need to get a common denominator of 2. So when we do that, we're going to get 2 times the square root of 3 over 2 minus the square root of 3 over 2. And these are like terms. So we have 2 of them minus 1 of them. So we just have the square root of 3 over 2. So 89 should just be the square root of 3 over 2. This is fun. So I hope that you're building up your repertoire of your angles, your different reference angles and what the values are. So as we do some of these, we're going to fill them in here. So cosecant is going to be 1 over sine. So that should be 1 here. And then secant is 1 over cosine. Oh, so that's going to be undefined. Undefined. Okay. So let's go to 97 and 100, 101, 97 and 101. So 97 and 101, they're asking us, 97 says, find an angle such that cosine of, oh, let me move my, where the angle S and T, where cosine of S equals the cosine of T. So I have to find an angle S where the cosine of pi over 4 equals that. Between, and S has to be an angle between 0 and 2 pi. Those are my restrictions, and it can't equal this T. So we have to figure out cosine of T. Let's look at that one. So that's what we have to match, right? Cosine of pi over 4. Let's just look at our sheet here. Pi over 4 for cosine is square root of 2 over 2. And at pi over 4, it's positive. So cosine is positive in the first quadrant, negative in the second quadrant, and negative in the third quadrant, and positive in the fourth. So we have to pick the reference, the angle that goes with pi over 4 in the fourth quadrant. And that's the pi over 4 angle. So we have to go down here. So that would be, and it can't be a negative. It has to be between 0 and 2 pi. So that means we're going to go all the way around just short of 2 pi. So it's going to be 2 pi minus a pi over 4 because we want to go back 1. So we want it to be this angle here. So 2 pi is the same as 8 pi over 4 minus a pi over 4. So I think it should be 7 pi over 4. And not I think, I'm confident that that's what it should be. 7 pi over 4. So S should be 7 pi over 4. And the cool thing is we can check our answers because we're in radians mode. We can say cosine of pi over 4. okay, is 0.7071. And then we should be able to do sine of 7. Oh, we need sine. Oh, no, we need cosine. Cosine of this angle. Cosine of 7 pi over 4. And that should also be positive. So we did it correct. So S should be this. So we're looking for angles. They can't be the same angle. They have to be different and they have to be within the 0 to 2 pi. So 101 is a similar one. 101 says, okay. So 101, we just all mixed up. Says, find an angle S and T cannot equal each other such that sine of S equals the sine of T. So similar to what we just did, but we're talking about sine. Sine of S has to equal sine of T. And we want T is equal to pi. So sine of T is the sine of pi. And that would be right here because this is pi, and sine at pi is 0, right? So where else is sine 0? It's at 2 pi, 0 and 2 pi. So we could do 0, we could do 2 pi because that was an option as well. I don't think it had a restriction. Let's just see if the restriction was. The restriction was between 0 and it can't equal 2 pi, so it has to be the 0. So S must be 0. So the sine of 0 is 0. So the extra angle is 0. So I am sure you've learned a lot in the last 2 lessons. So make sure that you're getting started on the assignment early so that you can reach out and ask any questions that you might have for me. I'm happy to meet you on the Zoom, as I've been mentioning all semester. And catch me back for lesson 5.3. We're going to start using all of these little bits and pieces that we've been learning.